Okay, let's take a look at review problem 4.1. Let's suppose that 15% of families in a certain community have no children, 20% have one child, 35% have two children, and 30% have three children. Suppose further that in each family, each child is equally likely to be a boy or a girl. If family is chosen at random from this community, and let B and G be the number of boys and girls respectively in the family that's chosen. The first question is find the joint distribution of B and G. Okay, so to get started on this problem, we will first draw a tree diagram. So let N be the number of children in the family that's selected. And we'll also let B be the number of boys. And let G be the number of girls. Okay, so then we have four possibilities for the value of N. So N could be equal to 0, N could be equal to 1, N could be equal to 2, or else N could be equal to 3 for the number of children. And each of these has a given probability in the problem. So the probability of this happening is 15%. The probability of one child is 20%. The probability of two children is 35%. And the probability of three children is 30%. Okay, now if there are 0 children, then clearly there's a 100% chance that there's 0 boys and 0 girls. So the chance of that happening is 100%. If there's one child in the family, then there are two possibilities. The child could be a boy with probability 50%, or the child could be a girl with probability 50%. And therefore, if there's one boy, then there's 0 girls, and if there is one girl, then there are 0 boys. Now, if there are 2 children, the number of boys in the family, as well as the number of girls, but the number of boys in the family would follow a binomial distribution. And so this follows a binomial distribution with parameters 2 and 1/2. And so the probabilities are 0.25, 0.5, and 0.25 using the properties of a binomial distribution. And if there are 0 boys, then there are 2 girls. If there's 1 boy, then there's 1 girl. If there are 2 boys, there are 0 girls. And lastly, if there are 3 children in the family, then once again the number of boys in the family will follow a binomial distribution. So the number of boys could be 0, 1, 2, or 3. And the probabilities here will follow a binomial distribution with parameters 3 and 1/2. And if we just use the binomial distribution, this works out to be 1/8, 3/8, 3/8, and 1/8. Just simply using the binomial distribution with k equals 0, 1, 2, and 3. And if there are 0 boys, then there are 3 girls. If there's 1 boy, there are 2 girls. If there's 2 boys, there's 1 girl. And if there are 3 boys, then there are 0 girls. Okay, so from this chart, we can now figure out the joint distribution. So let me keep this chart here, and I'll write the joint distribution next to it. Okay, so let's lay out a table. The probability of 0 boys, 0 girls. The probability of 1 boy, 0 girls. The probability of 2 boys, 0 girls. The probability of 3 boys, 0 girls. And then working across, the probability of 1 boy, 0 girls. The probability of 1 boy, 1 girl. The probability of 1 boy, 2 girls. Sorry, I got this backwards. I want to keep the number of girls fixed. So 1 here, 1 here, 1 here, 0 boys, 1 boy, 2 boys, and then probability of 3 boys, 1 girl. Continuing on, we need to figure out the probability of 0 boys, 2 girls, probability of 1 boy, 2 girls, probability of 2 boys, 2 girls, and the probability of 3 boys, 2 girls. And to finish the chart, probability of 0 boys, 3 girls, probability of 1 boy, 3 girls, probability of 2 boys, 3 girls, and the probability of 3 boys, 3 girls. And so filling out this 4x4 table will be the joint distribution of B and G, which is the whole point, find the joint distribution of B and G. All right, a few of these are silly. So the chance of having 3 boys, 0 girls is, 3 boys, 1 girl is 0, because at most there are 4 children total, based on the assumptions of this problem. Likewise, you can't have 4 children here, can't have 5 children, can't have 4 children, can't have 5, can't have 6. So in this problem, those are easily found to be 0. Okay, now let's look at the tree diagram to fill out the rest of the table. The probability of 0 boys, 0 girls will be equal to 0.15 times 1, which is 0.15. The probability of 1 boy, 0 girls, that occurs here, and that's 0.2 times 0.5, which is 0.1. The probability of 2 boys, 0 girls would be 0.35 times 0.25. So 0.35 times 0.25 works out to be 0.0875. The probability of 3 boys, 0 girls would be 0.3 times 0.125, which works out to be 0.0375. Continuing to work, the probability of 0 boys, 1 girl would be down here. So that's 0.2 times 0.5, which is 0.1. The chance of 1 boy, 1 girl is going to be this ending, so 0.35 times 0.15, which is 0.175. Next, the probability of 2 boys, 1 girl, 2 boys, 1 girl is going to be right here, so 0.3 times 0.375. Multiplying, we get 0.1125. All right, continuing on to the next column. The probability of, and let me just fold this paper over so we can see it all on one screen. The probability of 0 boys, 2 girls is going to be right here, so 0.35 times 0.25, and so that works out to be 0.0875. The probability of 1 boy, 2 girls, that's right here, so 0.3 times 0.375 is 0.1125. And lastly, the probability of 0 boys, 3 girls would be 0.3 times 0.17 or 0.125, so that's 0.0375. And so if we take a look at this whole chart, that is the joint distribution of B and G. This big 4x4 chart. Okay, problem number 2. Find the conditional distribution of G given that B is equal to 1. Find the conditional distribution of G given that B is equal to 1. Okay, so that means, in other words, we need to figure out the probability of that G equals 0 given that B equals 1. We need to figure out the probability that G equals 1 given that B equals 1. And we also need to figure out the probability that G equals 2 given that B equals 1. And I'm not going to include the 3 case because if there's 1 boy, then there cannot possibly be 3 girls in the assumption of this problem. Okay, so to get started on this, I first have to figure out the probability that B is equal to 1. The probability that B equals 1 I get by adding along this row. So the chance that B equals 1 will be 0.1 plus 0.175 plus 0.1125. And so that is equal to 0.3875. So the chance that g is equal to 0 given that b equals 1, that's the probability that g equals 0 and b equals 1, divided by the probability that b equals 1. And so that's equal to the chance that g equals 0, b equals 1, that is right here, 0.1, divided by the chance that b equals 1, which is 0.3875. And so this works out to be approximately 0.2581, just plug in the calculator. The second one, the probability that b is equal to 1 and g equals 1, divided by the probability that b equals 1. So that is equal to the probability that b equals 1 and g equals 1, that's 0.175, divided by 0.3875, and so that works out to be approximately 0.4516. And finally, the last conditional probability is the probability that b is equal to 1 and g is equal to 2, divided by the probability that b equals 1. So that's equal to 0.1125 divided by 0.3875, and that works out to be approximately 0.2903. And if I add all three of these up, I get 1, which is not surprising because the sum of these three numerators is known to be equal to the denominator. So there is the answer for part 2. So part 1 is up here, part 2 is down here. The conditional distribution of g given that b is equal to 1. Part 3 of the problem, and well, let's just look at part 3 and part 4. Part 3 and part 4 says to find the expected value of g given that b is equal to 1 and the standard deviation of g given that b is equal to 1. So I just simply use these three probabilities to find the expected value of g and the standard deviation of g under this condition that b is equal to 1. So the expected value of g given that b is equal to 1 will be equal to 0 times 0.2581 plus 1 times 0.4516 plus 2 times 0.2903, and that works out to be 1.0322, plugging in the calculator. To find the standard deviation, I first figure out the expected value of g squared, given that b is equal to 1. So that's 0 squared times 0.2581 plus 1 squared times 0.4516 plus 2 squared times 0.2903. Plugging in a calculator, I get 1.6129, and therefore I find that the standard deviation of g, given that b equals 1, is equal to the square root of 1.6129 minus 1.0322 squared, and that works out to be approximately 0.7398. Okay, so I find the expected value and the standard deviation, the conditional expected value and conditional standard deviation, in much the same way that I found the expected value and the standard deviation at the start of the semester.